From the depths of the ocean to the vast reaches of space, and even some quirky corners of everyday life, these incredible truths are guaranteed to make you question everything you thought you knew.
The phenomenon of cold welding occurs when two clean, flat surfaces of metal come into contact in a vacuum or space environment, causing them to fuse together permanently. This occurs because, in the absence of an oxidized or contaminated layer, like dirt or oil that typically exists on Earth, the atoms of each metal surface do not know they belong to separate objects. Instead, they recognize the other surface as an extension of their own structure. This results in the formation of a single, continuous piece of metal, as if they were originally forged as one. In space, the conditions are ideal for cold welding because of the vacuum environment, which eliminates the protective oxide layers that form on metals under Earth's atmospheric conditions. On Earth, these oxide layers and impurities generally prevent atoms from bonding when two metal surfaces come into contact. However, in the vacuum of space, these barriers are absent, and when two metals meet with sufficient force or contact area, their atoms can interdiffuse, creating a strong bond. This phenomenon has implications for engineering and the design of spacecraft and satellites. Engineers take precautions to prevent unintended cold welding, such as using coatings, lubricants, or non-metallic materials to separate metal components. Cold welding can cause problems in mechanical systems with moving parts like joints, hinges, or bearings, as components could seize up and become inoperable. At the same time, cold welding can also be harnessed for intentional purposes, such as repairing or constructing structures in space without requiring heat or additional materials. Interestingly, cold welding is a purely physical process and does not rely on any additional energy input like heat, electricity, or pressure beyond the initial contact force. This makes it a fascinating example of how the behavior of materials can differ dramatically depending on environmental conditions, highlighting the unique challenges and opportunities of working in space environments.
The Sun, a vast sphere of glowing plasma, dominates the solar system by comprising 99.86% of its total mass. This staggering figure highlights its immense gravitational influence, which governs the orbits of planets, moons, asteroids, comets, and other celestial objects. With a mass approximately 330,000 times that of Earth, and a volume capable of holding over 1.3 million Earths, the Sun is the central anchor of the solar system, ensuring its stability and continuity. The Sun's massive composition primarily consists of hydrogen, about 74% by mass, and helium, approximately 24%, with trace amounts of heavier elements like oxygen, carbon, neon, and iron. These elements exist in a plasma state due to the extreme temperatures and pressures at its core, where nuclear fusion occurs. This fusion process converts hydrogen into helium, releasing vast amounts of energy that radiate outward as sunlight. This energy sustains life on Earth and drives the climate, weather, and ecosystems. Its gravitational pull is also crucial in maintaining the orbits of the planets. Without its overwhelming mass and corresponding gravitational force, the solar system's delicate balance would collapse, and celestial bodies would drift into space. The Sun's mass also contributes to phenomena such as tidal forces and the shaping of planetary atmospheres. For instance, the solar wind, a stream of charged particles emitted by the Sun, interacts with planetary magnetic fields and atmospheres, influencing auroras and geomagnetic storms. The Sun's dominance isn't merely physical, its mass defines the solar system's boundaries, extending even beyond the heliosphere to the distant Oort cloud. Despite its massiveness, the Sun is considered a medium-sized star, a G-type main sequence star, and its life cycle is expected to span about 10 billion years. Currently, at roughly 4.6 billion years old, it is in its middle age, continuing to fuel the solar system with its vast reservoir of energy.
Uranus, the seventh planet from the Sun, presents fascinating extremes when it comes to its rotation and orbital characteristics. A day on Uranus lasts about 17 hours, which is the time it takes for the planet to complete one full rotation on its axis. However, its year lasts 84 Earth years, the time it takes to complete one orbit around the Sun. These measurements reveal striking contrast between Uranus's day-night cycle and its seasons. A short day. 17 hours. Uranus rotates relatively quickly for a planet of its size, completing a full spin on its axis in just 17 hours and 14 minutes. However, this rotation is unusual because of the planet's extreme axial tilt of about 98 degrees. Unlike other planets, which spin more or less upright relative to their orbital planes, Uranus essentially rotates on its side. This makes its rotation retrograde, meaning it spins in the opposite direction to most planets like Earth or Mars. As a result of this tilt, each pole alternates between experiencing 42 years of continuous daylight, followed by 42 years of darkness during Uranus's orbit around the Sun. This unique orientation gives Uranus some of the most extreme seasonal changes in the solar system, even though the day itself is relatively short. A long year, 84 Earth years. While Uranus spins quickly on its axis, it moves more slowly along its orbit due to its distance from the Sun, an average of about 2.9 billion kilometers, or 1.8 billion miles. Its vast orbital path means it takes 84 Earth years to complete a single trip around the Sun. For perspective, this means a single Uranian season lasts about 21 Earth years, with each of the 4 seasons stretching over decades. The combined effect of day and year. The combination of a short day and a long year creates unusual dynamics on Uranus. For much of its orbit, especially near the solstices, one hemisphere experiences constant sunlight or darkness, depending on its orientation to the Sun. Near the equinoxes, when the Sun is aligned with the equator, Uranus experiences a more Earth-like day-night cycle, albeit with each day lasting only 17 hours. These factors make Uranus a fascinating study in planetary science. Its rapid rotation, extreme axial tilt and long orbit contribute to its unique climatic and observational characteristics. These features also influence its atmosphere, which is composed mostly of hydrogen, helium and methane, and result in dynamic weather patterns, including massive storms and high-speed winds, despite its frigid temperatures.
Titan, the largest moon of Saturn, is one of the most intriguing bodies in the solar system due to its thick atmosphere and surface features resembling Earth's hydrological cycle. With a diameter of about 5,150 kilometers, it is larger than Mercury and the second largest moon after Jupiter's Ganymede. Titan's atmosphere is dense and predominantly composed of nitrogen, about 98%, with small amounts of methane and other hydrocarbons. This nitrogen-rich atmosphere, the only one of its kind among moons, creates a hazy orange appearance due to the presence of complex organic molecules called tholins, formed by interactions between sunlight and atmospheric methane. The most fascinating aspect of Titan is its methane-based hydrological cycle, which is analogous to Earth's water cycle. Instead of water, Titan has rivers, lakes and seas of liquid methane and ethane. These hydrocarbon liquids are stable on Titan's frigid surface, where temperatures average around -179 degrees Celsius or -290 degrees Fahrenheit. Titan's largest seas, such as Kraken Mare and Ligeia Mare, are located near its poles and can span hundreds of kilometers. Methane rain falls from its thick clouds, replenishing these bodies of liquid in a process similar to the rain and river systems on Earth. The surface of Titan is a mix of icy terrain, sand dunes and liquid reservoirs, sculpted over time by erosion, tectonic activity and cryovolcanism. Beneath its surface, scientists believe Titan may harbour a subsurface ocean of water mixed with ammonia, raising tantalizing possibilities about the moon's potential for hosting life. NASA's Cassini spacecraft, along with the Huygens probe that landed on Titan in 2005, has provided detailed observations of its atmosphere, weather patterns and geology, offering a glimpse into a world both alien and familiar. The presence of organic molecules and an active climate system makes Titan a prime target for future exploration. NASA's upcoming Dragonfly mission, set to launch in 2027, aims to explore Titan's surface using a rotorcraft lander. This mission will investigate the Moon's chemistry and habitability, potentially revolutionizing our understanding of life in the universe.
The discovery of an enormous cloud of alcohol in space is a testament to the complexity and abundance of organic molecules in the cosmos. This giant cloud, formerly known as Sagittarius B2, is located near the center of the Milky Way, about 390 light-years from the supermassive black hole Sagittarius A*. It is a vast molecular cloud spanning about 150 light-years, making it one of the largest known repositories of organic molecules in our galaxy. Sagittarius B2 is composed of a rich mix of gases, including ethyl alcohol or ethanol, the same kind of alcohol found in alcoholic beverages. Scientists estimate that the cloud contains enough ethanol to produce about 400 trillion pints of beer. However, the alcohol isn't in a form that's drinkable or harvestable. It exists as a vapor mixed with other complex and often toxic compounds. The temperatures and pressures in this region make it a fascinating laboratory for studying the chemistry of organic molecules under extreme conditions. This molecular cloud is a hotbed of prebiotic chemistry containing more than 50 identified complex molecules, including amino acids and other building blocks of life. The abundance of organic molecules suggests that the basic chemistry for life might be widespread in the universe. The abundance of organic molecules suggests that the basic chemistry for life might be widespread in the universe. The discovery of these molecules supports the idea that organic compounds could be delivered to nascent planets via comets, asteroids, or interstellar dust, potentially seeding the precursors to life. Sagittarius B2 is also of significant interest to astronomers because it provides insights into the processes of star formation. The cloud is densely packed with regions of active star formation where collapsing gas and dust are giving birth to new stars. The discovery of alcohol and other organic molecules in Sagittarius B2 was made using radio telescopes, which detect the specific frequencies emitted by molecules as they rotate and vibrate. These emissions allow researchers to identify the chemical fingerprints of substances in distant interstellar clouds, even if they are thousands of light-years away. This finding underscores the complexity of interstellar chemistry and highlights the role that molecular clouds play in shaping the chemical landscape of the universe.
Neutron stars are among the most extraordinary and extreme objects in the universe. They are the remnants of massive stars that have undergone a supernova explosion and collapsed under their own gravity. After the explosion, the core of the star is compressed to the point where protons and electrons combine to form neutrons, resulting in an object with an incredibly small radius, typically about 10 to 12 kilometers, but an immense mass, often 1.4 times that of the Sun. This immense compression gives neutron stars their astounding density. To put their density into perspective, a sugar cube-sized amount of neutron star material would weigh about 1 billion tons, equivalent to the combined mass of all humans on Earth. This unimaginable density arises because neutron stars are essentially giant atomic nuclei made almost entirely of neutrons. The atoms are stripped of their electrons, and their nuclei are crushed together, leaving no empty space. This makes neutron stars vastly denser than ordinary matter. The gravitational pull of a neutron star is equally extraordinary. Its gravity is so strong that it can warp space-time around it, significantly affecting nearby objects. For example, if you were to stand on the surface of a neutron star, an impossible feat due to the extreme conditions, you would weigh billions of times more than you do on Earth. Even light cannot escape easily from the gravitational field of a neutron star, and time dilation effects near its surface would be extreme.
First of all, what went through my mind is how stupid am I to picture...
Neutron stars also exhibit remarkable physical phenomena due to their density and rapid rotation. Many neutron stars are observed as pulsars, which emit beams of electromagnetic radiation from their magnetic poles. These beams sweep across space as the neutron star rotates, creating a lighthouse-like effect. Pulsars can rotate astonishingly quickly, with some spinning hundreds of times per second, a rate maintained due to their conservation of angular momentum after the collapse of the parent star. The composition of neutron stars is a subject of ongoing scientific investigation. The outer crust consists of a dense lattice of atomic nuclei and a sea of degenerate electrons, while the inner layers may harbor exotic states of matter, such as superfluid neutrons or quark-gluon plasma, where quarks, the fundamental building blocks of protons and neutrons, exist freely. Studying neutron stars provides invaluable insights into fundamental physics, including the behavior of matter at extreme densities, the nature of strong nuclear forces, and the properties of space-time under intense gravity. Observations of neutron stars, particularly through gravitational waves emitted during their collisions, as in neutron star mergers, have opened new frontiers in understanding the universe's most extreme conditions.
Venus, the second planet from the Sun, holds the title of the hottest planet in the solar system, despite being farther from the Sun than Mercury. This surprising fact is due to Venus's thick atmosphere, which creates a runaway greenhouse effect, trapping immense amounts of heat and causing surface temperatures to soar to an average of about 475 degrees Celsius or 900 degrees Fahrenheit. These temperatures are hot enough to melt lead and are consistent across the planet, day or night, poles or equator. In contrast, Mercury, which is the closest planet to the Sun, lacks a substantial atmosphere to trap heat. While Mercury's daytime surface can reach scorching temperatures of around 430 degrees Celsius or 800 degrees Fahrenheit, its lack of atmospheric insulation allows temperatures to plummet to about minus 180 degrees Celsius or minus 290 degrees Fahrenheit at night. Venus, on the other hand, maintains its blistering heat due to its dense atmosphere, composed of about 96.5% carbon dioxide with traces of nitrogen and clouds of sulfuric acid. Venus's greenhouse effect is driven by its atmospheric composition and extreme pressure, which is about 92 times that of Earth's at sea level. This means standing on Venus would feel like being 900 meters or 3,000 feet underwater on Earth. The thick CO2 atmosphere traps solar energy effectively, allowing heat to build up over time. The thick sulfuric acid clouds further contribute by reflecting sunlight, but this does little to offset the immense heat retained by the greenhouse effect. Another factor contributing to Venus's extreme temperatures is its slow rotation. A day on Venus lasts about 243 Earth days, longer than its year, which is 225 Earth days. This slow rotation results in minimal day-to-night temperature variation, as the thick atmosphere efficiently redistributes heat around the planet. The conditions on Venus have made it a subject of intense scientific study. Venus's past may have been more Earth-like, with evidence suggesting it could have once had oceans and a habitable climate before the runaway greenhouse effect took hold. Understanding Venus's evolution provides critical insights into climate dynamics and helps scientists study the potential for similar scenarios on Earth or exoplanets. Despite its extreme environment, Venus continues to intrigue researchers. Its surface is obscured by thick clouds, but radar mapping missions like NASA's Magellan and the upcoming Veritas mission aim to unveil its geology and history. By studying Venus, we not only learn about our neighboring planet, but also gain perspective on planetary atmospheres, climate change, and the factors that make planets habitable.
The Moon is gradually moving away from Earth at a rate of about 1.5 inches, or 3.8 centimeters per year. This phenomenon is known as lunar recession. This slow drift has significant implications for the Earth-Moon system and is a result of complex gravitational interactions, particularly the tidal forces between the two bodies. The primary driver of this separation is the effect of tidal forces. As the Moon orbits Earth, its gravitational pull creates tidal bulges in Earth's oceans. Because Earth rotates faster than the Moon orbits, these tidal bulges are slightly ahead of the Moon in its orbit. The gravitational interaction between the Moon and these displaced tidal bulges creates a transfer of energy. Earth's rotation slows down slightly due to this interaction, and in response, the Moon gains angular momentum, causing its orbit to expand and move farther away from Earth. This process is extraordinarily gradual, but its effects are cumulative over long periods. The Moon was much closer to Earth when it first formed about 4.5 billion years ago, likely from a giant impact between Earth and a Mars-sized body called Theia. At that time, the Moon may have been as close as 14,000 miles or 22,530 kilometers from Earth, compared to its current average distance of about 238,855 miles or 384,400 kilometers. The recession rate has varied over geological timescales depending on factors such as Earth's rotation and the configuration of continents, which influence the tides. The Moon's recession affects more than just its distance from Earth. It also impacts Earth's rotation. As the Moon moves away, Earth's rotation slows down, lengthening the length of a day. Billions of years ago, a day on Earth may have lasted only 6 hours, compared to the current 24 hours. In the distant future, this process could result in tidal locking, where Earth's rotation period matches the Moon's orbital period, similar to how the Moon is tidally locked to Earth, always showing the same face. The changing Earth-Moon distance also has implications for phenomena such as eclipses. As the Moon moves farther away, its apparent size in the sky decreases. In the far future, it will no longer be large enough to completely cover the Sun during a total solar eclipse, meaning Earth will only experience annular eclipses. The recession rate is measured with high precision using lunar laser ranging experiments. Retro-reflectors left on the Moon by Apollo astronauts and robotic missions reflect laser beams sent from Earth, allowing scientists to measure the Moon's distance with millimeter accuracy. These measurements confirm the Moon's gradual drift and provide critical data for understanding the dynamics of the Earth-Moon system and its evolution over billions of years.
A neutron star is an astronomical marvel, a remnant of a massive star that has undergone a supernova explosion and collapsed under its own gravity. This collapse compacts the star's core to an astonishing density, making neutron stars some of the densest objects in the universe. To put this into perspective, a spoonful of neutron star material, roughly the size of a sugar cube, would weigh more than Mount Everest, around 10 to the power of 15 grams or about 1 billion tons. This unimaginable density arises from the fundamental nature of neutron stars. When a massive star exhausts its nuclear fuel, it can no longer sustain the pressure required to counteract gravity. This results in a catastrophic collapse, during which protons and electrons in the star's core are crushed together to form neutrons. The resulting neutron star is essentially a giant atomic nucleus, with its matter packed so tightly that a single cubic centimeter weighs billions of tons. The extreme density of neutron star matter means that its atoms are no longer in their familiar state. Instead, the electrons are stripped away and the nuclei are squeezed so closely together that the neutrons themselves dominate. The immense pressure overcomes the electrostatic forces that typically keep atoms apart, creating a state of matter far beyond what we encounter on Earth. Scientists hypothesize that the core of a neutron star might even harbor exotic forms of matter, such as hyperons or quark-gluon plasma, where quarks, the fundamental building blocks of protons and neutrons, exist freely. This density is difficult to imagine, but comparisons help illustrate it. For example, the entire human population of Earth, if compressed to the density of a neutron star, would fit into a space smaller than a sugar cube. Such extreme conditions also lead to incredibly strong gravitational fields, with the surface gravity of a neutron star being about 10 to the power of 11 times stronger than Earth's. Any object falling onto the surface would be accelerated to near-light speeds, releasing vast amounts of energy upon impact. The immense density and gravity of neutron stars also create a range of fascinating phenomena. For instance, neutron stars are often observed as pulsars, rapidly rotating objects that emit beams of electromagnetic radiation from their magnetic poles. These beams sweep across the sky as the star rotates, creating periodic signals that can be detected from Earth. Some neutron stars spin at incredible rates, with some rotating hundreds of times per second, due to the conservation of angular momentum during their formation. Studying neutron stars provides invaluable insights into fundamental physics, including the behavior of matter under extreme pressure and density, the limits of nuclear stability, and the nature of gravity. Observations of neutron star mergers, which produce gravitational waves and heavy elements like gold and platinum, further enhance our understanding of these extraordinary objects and their role in the universe's evolution.
A day on Mars, known as a sol, is remarkably similar in length to a day on Earth, lasting approximately 24 hours and 37 minutes. This makes Mars the planet in the solar system with a rotational period most comparable to Earth's. The slight difference of just 37 minutes has significant implications for future human exploration and colonization, as it allows for relatively straightforward adaptation to the Martian day-night cycle. Mars achieves this day length due to its rotation on its axis, which takes about 24 hours, 37 minutes and 22.7 seconds to complete. Like Earth, Mars rotates in a counterclockwise direction, resulting in a day-night cycle that is familiar to humans. This similarity simplifies the planning of human activities on Mars, as it reduces the need for drastic adjustments to biological rhythms compared to other planetary bodies with vastly different day lengths. This small difference in day length, however, accumulates over time, creating challenges for missions operating on both Mars and Earth time. For instance, the teams controlling Mars rovers, such as Perseverance and Curiosity, often synchronize their work schedules with the Martian sol to maximize communication and operational efficiency. This synchronization, known as Mars time, means working slightly later each day by 37 minutes, which can disrupt human circadian rhythms over long periods. Mars's day length is closely tied to its similarities to Earth in terms of axial tilt, which is 25.2 degrees compared to Earth's 23.5 degrees. This tilt causes Mars to have seasons like Earth, though they are longer because of Mars's longer orbital period, which is 687 Earth days. The combination of a familiar day length and a similar tilt makes Mars an appealing target for exploration, as it shares many environmental patterns with Earth, albeit with key differences such as its thinner atmosphere and colder temperatures. Understanding the Martian sol is crucial for planning human and robotic missions. Life support systems, energy generation, especially solar power, and activity schedules must account for this slightly extended day. For potential future colonies, adapting to a 24-hour, 37-minute cycle is considered manageable, especially compared to more drastic adjustments that would be required on planets like Venus, where a day lasts 243 Earth days, or Jupiter, where a day lasts just 10 hours. The close resemblance of a Martian sol to an Earth day is a reminder of Mars's potential as a second home for humanity. This similarity, combined with its proximity and relatively hospitable surface conditions compared to other planets, makes Mars a prime candidate for future exploration, settlement and possibly even terraforming. It serves as a key focus for current and future space missions, aiming to expand humanity's presence beyond Earth.
Honey's unique ability to resist spoilage has earned it a place of reverence throughout history. Its remarkable longevity was first discovered through archaeological findings, most notably in ancient Egyptian tombs, where pots of honey, sealed and preserved for thousands of years, were found to still be edible. These finds not only highlight honey's practical value in ancient times, but also its cultural and ceremonial significance. In ancient Egypt, honey was a luxury item, used in religious offerings, embalming practices, and as a cherished food item for the afterlife. Its presence in tombs was a testament to its perceived importance, serving both as sustenance for the dead and as a symbol of purity and immortality. The science behind honey's durability is as fascinating as its history. Honey's low water content, around 17%, combined with its high concentration of natural sugars, creates an environment where microorganisms cannot thrive. Most bacteria and fungi require water to grow, but the hygroscopic nature of honey, which allows it to absorb moisture from the air, keeps itself preserved when stored properly. Adding to its antimicrobial properties is the enzyme glucose oxidase, introduced by bees during honey production. This enzyme produces small amounts of hydrogen peroxide, further protecting honey from spoilage. Its natural acidity, with a pH ranging from 3 to 4.5, also creates a hostile environment for bacteria. In addition to its chemical properties, proper storage conditions have historically played a role in honey's longevity. The pots of honey found in ancient tombs were sealed tightly, keeping them safe from contaminants and air exposure. This airtight environment, combined with honey's intrinsic properties, created a perfect recipe for preservation. However, if honey is exposed to moisture or improperly stored, it can ferment or crystallize over time. Though this does not necessarily render it unsafe to eat, it simply alters its texture or flavor. Honey's role as a preservative and medicinal agent is well documented across cultures. Beyond the Egyptians, civilizations such as the Greeks and Romans used honey for its antimicrobial properties, treating wounds and illnesses. In Ayurvedic medicine, honey has been valued for thousands of years as a therapeutic food. Its durability and versatility made it a staple in trade, often serving as a form of currency or tribute. Today, honey continues to captivate with its blend of natural science and historical lore. It is not merely a sweetener but a marvel of natural engineering, a food that transcends time. The enduring mystery and utility of honey remind us of its importance to ancient civilizations and its ongoing relevance in modern culinary and medicinal practices. It stands as a testament to nature's ability to create a product that is as functional as it is delicious.
The history of ketchup as a medicine is a fascinating tale of early marketing, pseudoscience, and the shifting perceptions of food. In the early 19th century, the modern ketchup we know, made primarily from tomatoes, vinegar, and spices, was not yet a widespread household condiment. Instead, it was viewed as an exotic product with potential health benefits. This shift began largely due to the work of Dr. John Cook Bennett, a physician and professor who became a vocal advocate for the medicinal properties of tomatoes. At a time when tomatoes were just starting to gain acceptance in the Western diet, his claims helped to revolutionize their image. Bennett argued that tomatoes, rich in nutrients like vitamins A and C, could provide various health benefits. He went further, suggesting that concentrated tomato-based products like ketchup could cure common ailments of the time, including diarrhea, indigestion and jaundice, as well as more chronic conditions like rheumatism. His bold claims captured the public's imagination, and soon ketchup was not just a food product, but a purported remedy. Manufacturers saw an opportunity and began producing tomato-based pills, syrups and extracts marketed as patent medicines. This period coincided with a broader trend in the 19th century, where many food items and plant-based products were marketed as health cures. Patent medicines, often unregulated, were popular in an era when modern medical practices were still developing. Ketchup pills became part of this phenomenon, appealing to those seeking accessible and affordable remedies for common health complaints. While Bennett's claims were never scientifically validated, his work inadvertently helped increase the popularity of tomatoes and encouraged their integration into the American diet. However, ketchup's stint as a cure-all was short-lived. By the late 1800s, the burgeoning fields of chemistry and medicine began to challenge and debunk the exaggerated claims of patent medicines. Ketchup in particular was scrutinized and ultimately reclassified as a food product rather than a pharmaceutical one. At the same time, improvements in food production and preservation helped evolve ketchup into the tangy, shelf-stable condiment we know today. Brands like Heinz emerged, focusing on flavor and mass appeal rather than medicinal benefits. Today, ketchup's brief history as a medicinal product is a quirky footnote in its journey from an Asian-inspired fish sauce, its distant ancestor, to a global culinary staple. It also serves as a reminder of how food trends can intersect with health fads, often driven more by marketing and cultural attitudes than by scientific evidence.
Pineapples, one of the most beloved tropical fruits, have a surprisingly lengthy growth cycle that requires patience and care. It takes approximately 2 years for a pineapple to grow from a planting to a ripe, harvestable fruit. This extended timeline is a result of the plant's unique growth process and the specific conditions it requires to thrive. Pineapple plants begin as small offshoots, known as suckers or slips, which are either cultivated from the crown of a harvested fruit or propagated from other parts of the plant. Once planted, the pineapple plant goes through an initial growth phase of around 12 to 18 months, during which it develops its spiky, robust leaves. These leaves form a dense rosette-shaped structure that serves as the base of the plant. During this time, the plant absorbs nutrients and energy to prepare for fruit production. After this vegetative growth phase, the pineapple plant enters its reproductive stage, signaled by the emergence of a central flower stalk. This flowering process can take several months, during which the plant produces small purple or red flowers arranged in a tight spiral pattern. Each flower eventually develops into a berry-like fruit, and together, these individual fruits fuse to form the recognizable structure of a pineapple. Even after the fruit appears, it takes several additional months to mature fully. During this period, the pineapple changes color, grows larger, and accumulates the sugars that give it its sweet, tangy flavor. The exact timeline can vary depending on factors like climate, soil quality, and cultivation techniques. Pineapples thrive in tropical and subtropical regions with consistent warmth and sunlight, which are crucial for healthy growth and ripening. The lengthy growth cycle of pineapples makes them a relatively resource-intensive crop compared to faster-growing fruits. This is one reason why pineapples were historically considered a luxury item, symbolizing wealth and hospitality. Today, advances in agriculture have made pineapples more accessible, but their long cultivation time remains a challenge for farmers. Despite the time investment, the 2-year growth process ensures that pineapples develop their characteristic sweetness and juiciness, making them a worthwhile endeavor for growers and a favorite for consumers worldwide. Their slow maturation also highlights the intricate balance of natural processes that go into producing the food we enjoy.
Peanuts, the legume misunderstood as a nut. Peanuts, despite their name and common association with other nuts like almonds and walnuts, are not true nuts. Botanically, peanuts belong to the legume family, which includes beans, lentils, and chickpeas. This classification stems from their growth habits and the structure of their seeds, which differ significantly from those of tree nuts. Legumes are plants that produce seeds or pods, and peanuts fit this description perfectly. The peanut plant Arachis hypergaea is unique in its growth cycle. After its yellow flowers are pollinated, they form a structure called a peg, which bends downward and burrows into the soil. It is beneath the ground that the peanut pods develop, housing the seeds we consume as peanuts. This underground development is a hallmark of legumes and sets peanuts apart from nuts, which typically grow on trees. Nutritionally, peanuts are similar to tree nuts in many ways. They are rich in protein, healthy fats, fiber, vitamins, and minerals, making them a popular and nutritious food. However, their legume status is particularly significant for those with allergies, as peanut allergies are distinct from tree nut allergies. Some people allergic to tree nuts may tolerate peanuts and vice versa, although cross-reactivity is possible. Peanuts also play an important role in agriculture and sustainability. As legumes, they have the ability to fix nitrogen in the soil through a symbiotic relationship with nitrogen-fixing bacteria in their root nodules. This process enriches the soil, reducing the need for synthetic fertilizers and benefiting crop rotation systems. The confusion between peanuts and true nuts likely arises from their culinary use. Peanuts are often grouped with tree nuts in recipes and snacks because of their similar taste, texture, and versatility. From peanut butter to roasted peanuts, they have become a staple in diets worldwide, blurring the lines between botanical and culinary definitions. Understanding that peanuts are legumes rather than nuts offers insight into their unique biology and their broader significance in ecosystems and food systems. While they might not technically be nuts, peanuts remain a treasured and essential food source for cultures around the globe.
Apple seeds contain a compound known as amygdalin, a type of cyanogenic glycoside. When chewed or digested, amygdalin can break down into hydrogen cyanide, a toxic substance. While this fact might sound alarming, the amount of cyanide produced from consuming apple seeds is typically very small, and it would take a substantial quantity to pose any real health risk. Specifically, estimates suggest that consuming the seeds of around 18 to 20 apples, or over 200 seeds in total, could reach a dangerous level of cyanide for the average adult. The reason apple seeds contain amygdalin is likely a natural defense mechanism to deter herbivores from eating the seeds, which are vital for the plant's reproduction. This protective strategy is not unique to apples. Many plants in the rose family, including cherries, peaches, and almonds, also contain cyanogenic compounds in their seeds or pits. In practice, accidental ingestion of a few apple seeds is harmless, as the human body can process small amounts of cyanide efficiently. Furthermore, the seed's hard outer coating often prevents them from being digested unless they are thoroughly chewed. If swallowed whole, the seeds typically pass through the digestive system intact without releasing cyanide. Despite their potential toxicity in large amounts, apple seeds pose minimal risk in everyday consumption. To reach a lethal dose of cyanide, one would need to eat an unrealistic number of apple seeds in a short period. For most people, enjoying apples as part of a healthy diet poses no danger, provided the seeds are not intentionally consumed in large quantities. The cyanide in apple seeds is a reminder of nature's chemical complexity. While many plants produce compounds that can be toxic in large doses, they are generally harmless or even beneficial when consumed in moderation. This balance between risk and safety underscores the importance of understanding and respecting the natural compounds in the foods we eat.
The 100-year-old egg, also known as a century egg, preserved egg, or millennium egg, is a traditional Chinese delicacy that has a misleading name. Despite its evocative moniker, the egg is not aged for 100 years, but rather preserved for a period ranging from a few weeks to a few months. The process transforms the egg in texture, flavor, and appearance, creating a unique culinary experience. Century eggs are typically made using duck, chicken, or quail eggs, which are preserved through a chemical process. The traditional method involves coating the eggs in a mixture of clay, ash, salt, quicklime, and rice hulls, then allowing them to cure over time. Modern techniques often substitute alkaline substances like sodium carbonate and calcium hydroxide to expedite the process and achieve consistent results. During preservation, the pH of the egg rises dramatically, creating an alkaline environment that triggers significant chemical changes in the egg's proteins and fats. As a result of this process, the egg white becomes a translucent, amber-colored gel with a firm, jelly-like consistency. The yolk turns dark green or grey and develops a creamy texture with a rich umami flavour. The taste is often described as savoury, with hints of salt and sulphur, while the aroma can be strong and pungent, which may take some getting used to for the uninitiated. The century eggs are enjoyed in various ways across East and Southeast Asia. They can be eaten on their own, paired with pickled ginger, or used as an ingredient in dishes like congee salads or tofu-based appetizers. In Chinese cuisine, they are celebrated for their bold flavor and are considered a delicacy with cultural significance. The myth that century eggs are aged for a century likely arose from their striking transformation and the intense flavors that suggest long aging. However, the preservation process's efficiency means that it takes only a few weeks to months to achieve the desired effects. This culinary tradition showcases the ingenuity of food preservation techniques and the diverse ways humans have enhanced and extended the shelf life of natural ingredients. Century eggs continue to be a beloved and iconic food in many cultures, embodying the creativity and resourcefulness of traditional food practices. For those unfamiliar with the delicacy, trying a century egg can be an adventurous and rewarding culinary experience.
The statement Coca-Cola would be green if food coloring wasn't added is often circulated as a fun fact, but it is somewhat misleading. Coca-Cola's natural color without added caramel coloring isn't exactly green, but rather a light and murky hue that might appear greenish-brown. This natural coloration comes from the mix of its original ingredients, including the coca leaf extract, now replaced with a decoconized version, and cola nuts, which both have their own distinct colors. To achieve the iconic dark brown shade associated with Coca-Cola, manufacturers add caramel coloring, specifically a type known as Class 4 caramel coloring. This ingredient not only enhances the drink's visual appeal, but also aligns with consumers' expectations for the product. The consistent dark color has become a signature element of the brand and contributes to its globally recognized identity. Historically, the original Coca-Cola recipe, developed in the late 19th century by Dr. John Stiff Pemberton, did not include artificial food coloring as we understand it today. However, as the drink evolved into a commercial product, standardizing its appearance became crucial for branding purposes. The addition of caramel coloring ensures the beverage looks the same whether it's bottled in Atlanta, Tokyo, or Cairo. While the green Coca-Cola claim isn't entirely accurate, it does underscore the importance of color in the marketing and presentation of food and beverages. It also serves as a reminder of the meticulous processes involved in creating a product that millions consume daily.
Nutmeg, a common spice derived from the seed of the Myristica fragrance tree, has a lesser-known property. It can produce hallucinogenic effects if consumed in very large doses. This is due to the presence of myristicin, a naturally occurring compound found in nutmeg's essential oil. Myristicin is a psychoactive substance that, when ingested in high amounts, can affect the central nervous system, leading to altered perception, euphoria, and in some cases hallucinations. The hallucinogenic effects of nutmeg are not immediate. After consuming a large quantity, symptoms typically take several hours to manifest and can last for up to 24 to 48 hours. In addition to hallucinations, individuals may experience nausea, vomiting, dizziness, dry mouth, heart palpitations, and severe discomfort. The psychoactive experience is often described as unpleasant rather than enjoyable, making nutmeg an unlikely candidate for recreational use. The amount of nutmeg required to induce these effects varies depending on the individual's body weight and sensitivity, but it generally involves consuming several teaspoons of the spice. This is significantly more than the amounts typically used in cooking or baking, where nutmeg is added in small quantities for its warm, spicy flavor. Historically, nutmeg has been used in traditional medicine and folklore for its purported aphrodisiac and sedative properties. However, its psychoactive potential has also been known for centuries. In some cases, it has been used as a last resort intoxicant, particularly in prison settings or among individuals lacking access to conventional drugs. Despite this, nutmeg's effects are unpredictable and its toxicity makes it a risky choice. Excessive nutmeg consumption can be dangerous. High doses can cause nutmeg poisoning, characterized by symptoms such as confusion, agitation, and even seizures. In extreme cases, it can lead to organ failure or death. As a result, while nutmeg remains a safe and flavorful addition to food in small amounts, it is not recommended to consume it in large quantities for any purpose.
McDonald's once experimented with creating bubblegum-flavored broccoli as part of its efforts to develop healthier menu options for children. This unusual concept was devised in the early 2010s, during a period when the company faced criticism for contributing to childhood obesity and sought to improve its nutritional offerings. The idea was to make vegetables more appealing to children by incorporating flavors they already enjoyed, like bubblegum. The creation was part of a broader initiative to innovate and make healthy eating more accessible and enjoyable. However, the experiment backfired. While the bubblegum-flavored broccoli successfully intrigued some children, it left most confused and unimpressed. During focus group testing, children found the flavor combination strange and unappetizing. Instead of encouraging kids to eat their vegetables, it created a sense of bewilderment, as broccoli's natural texture and bubblegum's sweet artificial flavor didn't complement each other. The failure of bubblegum-flavored broccoli highlighted the challenges of altering children's eating habits through unconventional methods. It underscored that taste alone isn't enough to shift preferences. Factors such as texture, appearance, and familiarity also play critical roles. Additionally, parents and health advocates criticized the attempt, arguing that disguising vegetables with artificial flavors undermined the goal of teaching children to enjoy natural, healthy foods. After the idea flopped, McDonald's shifted its focus to more practical strategies for improving its menu, such as offering apple slices, yogurt, and milk in Happy Meals. The bubblegum broccoli experiment remains a quirky footnote in the company's history, illustrating the complexities of blending nutrition with consumer appeal, especially when catering to children.
Lobsters, now considered a luxury delicacy, were once regarded as food for the poor and marginalized. In colonial America and the 19th century, lobsters were so abundant along the northeastern coast of the United States that they were used as a cheap source of sustenance for prisoners, indentured servants, and the impoverished. The crustaceans were so plentiful that they would wash up on shores in large quantities, often piled several feet high after storms. At the time, lobsters were seen as unrefined and undesirable. They were nicknamed the cockroach of the sea due to their scavenger-like behavior. People even considered it shameful to eat lobster regularly, and there were reports of servants rebelling against being forced to consume it too often. In some areas, laws were passed to limit the number of times prisoners or servants could be fed lobster, typically to no more than a few times per week. The perception of lobster began to shift in the late 19th century with the development of transportation technologies, such as railroads, which allowed fresh lobster to be shipped to inland cities where it was marketed as an exotic delicacy. Additionally, the rise of fine dining establishments and the influence of chefs helped reframe lobster as a gourmet food. Tourists visiting coastal areas were also introduced to lobster as a luxurious treat, further boosting its appeal. By the mid-20th century, lobster had transitioned from being a low-cost, readily available food to a highly sought-after and expensive dish. This transformation was driven by changing societal attitudes, improved cooking techniques, and the increasing rarity of wild-caught lobsters due to overfishing and environmental changes. Today, lobster is a symbol of indulgence, often associated with celebrations and upscale dining. Its journey from a poor man's protein to a luxury item is a fascinating example of how food perceptions can evolve based on cultural, economic, and environmental factors.
Alaska is unique among the United States because it holds the distinction of being the westernmost, easternmost, and northernmost state in the country, a geographical oddity tied to its location and vast expanse. Alaska is the northernmost state because it extends far into the Arctic Circle, with its northernmost point, Point Barrow, Utqiagvik, sitting at a latitude of about 71 degrees north. This location makes it closer to the North Pole than any other US state. As the westernmost state, Alaska reaches farther west than Hawaii or any other state due to the Aleutian Islands chain. These islands stretch across the 180th meridian into the eastern hemisphere, placing parts of Alaska at the edge of the Western world. While it might seem counterintuitive, Alaska is also the easternmost state. This is because the Aleutian Islands cross the 180th meridian of longitude, which is the dividing line between the eastern and western hemispheres. Since longitude increases eastward from the prime meridian, 0 degrees, the islands west of the 180th meridian technically lie in the eastern hemisphere, making them the easternmost point of the United States. This combination of extremes is a testament to Alaska's vast size and unique position on the globe. With an area of over 663,000 square miles, Alaska is by far the largest U.S. state, larger than the combined size of the next three largest states, Texas, California, and Montana. Its geographic diversity and strategic position make it a fascinating region, blending Arctic tundra, coastal shores, and volcanic islands, all while holding a special place in global geography.
Canada is renowned for its abundance of freshwater lakes, holding the remarkable distinction of having more lakes than the rest of the world combined. This incredible natural feature is a result of the country's vast size, glacial history, and unique geography. Canada is home to an estimated 2 million lakes, with around 31,000 of them covering areas larger than 3 square kilometers, or 1.2 square miles. This unparalleled number of lakes is due largely to the retreat of glaciers during the last ice age. As the glaciers receded, they carved out depressions in the land, which later filled with meltwater, forming countless lakes. These glacially sculpted basins can be found across the country, from the pristine wilderness of British Columbia to the Arctic tundra. Some of the world's largest lakes are found in Canada, including the Great Lakes, which it shares with the United States, and several entirely within its borders, such as Great Bear Lake and Great Slave Lake. Great Bear Lake, located in the Northwest Territories, is the largest lake entirely within Canada and the 8th largest lake in the world. These lakes serve as critical ecosystems for wildlife, resources for human populations, and stunning destinations for recreation and tourism. Canada's lakes hold an immense amount of the world's fresh water, about 20% of the global supply. This makes the country one of the most water-rich nations on Earth, a vital resource in an era of increasing water scarcity. The abundance of lakes also plays a significant role in Canada's climate, economy, and culture, providing opportunities for fishing, transportation, and hydroelectric power generation. While many countries boast beautiful lakes, none come close to matching Canada's sheer volume. For example, countries like Finland, often nicknamed the Land of 1,000 Lakes, have significantly fewer lakes than Canada. Canada's vast and sparsely populated landmass allows for the preservation of these water bodies, ensuring that many remain pristine and relatively untouched by human activity. Canada's dominance in the world of lakes is a testament to its glacial past and vast geography, making it a global leader in freshwater resources and a haven for nature lovers.
Iceland, often referred to as the land of fire and ice, is the only country in the world without mosquitoes. This unique distinction has fascinated scientists and travelers alike, as mosquitoes are among the most widespread insects thriving in various climates worldwide. Despite Iceland's proximity to regions with large mosquito populations such as Greenland and Scandinavia, these pests have never successfully established themselves on the island. Several factors contribute to Iceland's mosquito-free status. The country's cool climate and frequent temperature fluctuations are believed to disrupt the life cycle of mosquitoes, particularly during their larval stage. Mosquitoes require stable conditions with standing water for their eggs and larvae to develop, but Iceland's volcanic terrain, glacial runoff and dynamic weather patterns limit the availability of suitable breeding grounds. Additionally, the country's water systems are often either too cold or too fast-flowing to support mosquito larvae. Another theory points to Iceland's relative isolation and stringent customs regulations, which may have prevented mosquitoes from being introduced. Unlike other countries, Iceland has no native mosquito population to adapt to its environment, and incoming mosquitoes, often hitchhiking on travellers or cargo, fail to survive the inhospitable conditions. For visitors, Iceland's lack of mosquitoes is an added perk, allowing them to explore its breathtaking landscapes without the nuisance of bites or the need for insect repellents. This unique aspect of Icelandic life is often highlighted by locals as a point of pride, adding to the allure of a country already renowned for its natural wonders.
Africa, a vast and diverse continent, holds the unique distinction of being the only continent located in all 4 hemispheres of the Earth: northern, southern, eastern and western. This geographical phenomenon is made possible by the intersection of the equator and the prime meridian, which pass through Africa and divide the planet into hemispheres. The equator traverses the continent roughly in the middle, cutting through countries such as Gabon, Congo, Uganda, Kenya and Somalia, placing parts of Africa in both the northern and southern hemispheres. Meanwhile, the prime meridian runs through Ghana, Mali and several neighbouring nations, situating portions of Africa in both the eastern and western hemispheres. This positioning makes Africa one of the most geographically diverse continents, influencing its climate, ecosystems and cultures. The continent spans a wide range of environments, from the Mediterranean climate in the north to the tropical rainforests near the equator and down to the arid deserts and savannas of the south. Africa's geographic spread across all hemispheres contributes to this variety, as the equator creates equatorial zones of high biodiversity, while the division by the prime meridian emphasizes the continent's global centrality. The fact that Africa lies in all 4 hemispheres also enhances its significance in global geopolitics and trade. Historically, this central location has made Africa a crossroads for civilizations, facilitating the exchange of goods, ideas, and cultural practices. Today, it underscores Africa's strategic importance in connecting different parts of the world. The continent's hemispherical placement also means that it experiences both equatorial and temperate climatic influences, shaping diverse agricultural systems and ways of life. Africa's hemispheric uniqueness is not just a geographical fact. It symbolizes the continent's central role in the Earth's interconnected systems. From influencing global climate patterns to its position as a hub for biodiversity and human culture, Africa's location across all 4 hemispheres is a remarkable testament to its pivotal place in the world.
Mount Everest, standing at a staggering height of 8,848.86 meters, which is 29,031.7 feet, is a symbol of natural grandeur and an ever-changing geological marvel. Its continued growth at an average rate of about 4 millimeters per year is a direct result of tectonic forces that have been shaping the region for tens of millions of years. This growth is tied to the collision of the Indian and Eurasian tectonic plates, a process that began around 50 million years ago when the Indian plate began its northward movement, eventually crashing into the Eurasian plate. This collision caused the Earth's crust to crumple, fold, and thrust upward, forming the Himalayan mountain range, with Mount Everest as its crown jewel. The ongoing growth of Mount Everest is not uniform but rather part of a complex interplay of forces. The tectonic push from the Indian plate is the primary driver, forcing the Himalayan region upward. However, natural forces such as erosion from wind, rain, and glacial activity act to counterbalance this upward movement. These erosive processes gradually wear down the peaks, demonstrating a delicate balance between growth and decay. Despite this, the uplift caused by tectonic activity has remained slightly dominant over millions of years, allowing Mount Everest to retain its position as the highest peak on Earth. Modern technology has revolutionized our ability to measure and understand the growth of Mount Everest. Using tools such as global positioning system devices, satellite imagery, and sophisticated laser scanning, scientists can now track minute changes in the mountain's height with extraordinary precision. For example, during a 2020 survey, Nepal and China jointly measured the peak's height, incorporating advanced techniques to ensure accuracy. Such measurements not only confirm Everest's annual growth, but also provide critical data for understanding the dynamics of Earth's crust in this region. Interestingly, Mount Everest's growth is not always steady. Sudden, dramatic events like earthquakes can cause temporary changes in the mountain's height and structure. For instance, the devastating Gorkha earthquake that struck Nepal in 2015 caused a slight subsidence in the surrounding region, with some areas sinking while others rose. Although Mount Everest itself was largely unaffected in terms of height, this event highlighted how seismic activity can reshape the region in an instant. In the long term, however, the tectonic forces responsible for the mountain's growth tend to overshadow these episodic disruptions. Mount Everest's ongoing rise serves as a reminder of the dynamic nature of Earth's surface. It is a living testament to the immense power of plate tectonics, a process that continues to shape not only the Himalayas, but also the landscapes of our entire planet. As scientific research and monitoring techniques advance, our understanding of Mount Everest's growth and its connection to Earth's broader geological systems will continue to deepen, offering valuable insights into the forces that sculpt our world.
The Dead Sea, a unique hypersaline lake located at the lowest point on Earth's surface, is renowned for its extraordinary buoyancy, allowing people to float effortlessly on its surface. This phenomenon occurs because the Dead Sea's salinity is exceptionally high, about 34%, nearly 10 times saltier than most oceans. The elevated salt content significantly increases the water's density, making it easier for the human body to stay afloat without any effort. This natural buoyancy is one of the key reasons the Dead Sea attracts visitors from around the world. The high salinity of the Dead Sea is the result of its unique geographical and climatic conditions. Situated in a desert region, the lake receives minimal rainfall and has no outlets for its water to flow into other bodies. Instead, water entering the Dead Sea from its main tributary, the Jordan River, and occasional rainfall only leaves through evaporation. The intense heat of the region accelerates evaporation, leaving behind high concentrations of salts and minerals. Over time, this process has created one of the saltiest bodies of water on Earth. The water of the Dead Sea is rich in various minerals, including magnesium, potassium and calcium chloride, which not only contribute to its salinity but also provide therapeutic properties. The mineral-rich mud and water are believed to have healing benefits, making the Dead Sea a popular destination for wellness tourism. Its environment has been used to treat skin conditions such as psoriasis and eczema, as well as to promote relaxation and skin rejuvenation. Floating in the Dead Sea is a surreal experience, but the extreme salinity also comes with some caveats. The water can be harsh on the skin and eyes, causing irritation if splashed into the face or if there are any cuts or abrasions. Furthermore, drinking the water or prolonged exposure can be harmful due to its mineral composition. Despite these precautions, the Dead Sea remains a sought-after location for its unparalleled natural phenomenon. Interestingly, the Dead Sea is shrinking at an alarming rate due to human activity and climate change. Diversion of water from the Jordan River for agricultural and industrial use has significantly reduced the inflow into the lake, causing its water levels to drop by over 1 metre per year. This has led to environmental concerns and efforts to mitigate its decline, such as projects to bring water from the Red Sea to replenish the Dead Sea. Whether such efforts will be sufficient to preserve this natural wonder remains uncertain. The Dead Sea's unique ability to allow people to float effortlessly, combined with its mineral-rich composition and striking desert landscape, makes it one of the most fascinating natural landmarks in the world. It stands as a testament to the diverse and extreme conditions that can exist on our planet, providing both recreational and scientific value.
The statement that Russia is bigger than Pluto is a fascinating comparison that underscores the sheer size of the Earth's largest country and the relatively small size of this distant dwarf planet. Russia spans an incredible 17.1 million square kilometers, making it the largest country on Earth by land area. It covers roughly 1/8 of the planet's total landmass, stretching across 11 time zones and encompassing a diverse range of landscapes, including tundra, forests, mountains, and plains. Pluto, on the other hand, is a celestial body that was once considered the 9th planet in our solar system, but was reclassified as a dwarf planet in 2006 by the International Astronomical Union. Its total surface area is estimated to be about 16.7 million square kilometers, which is slightly smaller than Russia's land area. This surprising fact highlights the diminutive size of Pluto, despite it being a significant object in the Kuiper Belt, a region of icy bodies beyond Neptune. The comparison is intriguing because it challenges common perceptions about planetary bodies. While Pluto might be imagined as enormous due to its planetary status in popular culture, its small size becomes apparent when measured against familiar earthly landmarks like Russia. This discrepancy arises from the fact that celestial bodies vary greatly in size, and not all planets or dwarf planets are comparable to Earth in scale. Russia's vast size contributes to its geopolitical and cultural significance. The country is home to a wide array of natural resources, ecosystems and climates, which have played a critical role in its history and economy. Its landmass includes Siberia, one of the most expansive and resource-rich regions on the planet, further emphasizing its global importance. Pluto, while smaller, is equally fascinating for entirely different reasons. Its surface features include vast plains of nitrogen ice, towering water ice mountains, and a thin atmosphere composed primarily of nitrogen with traces of methane and carbon monoxide. Pluto's exploration has been limited, but the 2015 flyby by NASA's New Horizons spacecraft provided humanity with the first detailed images and data of this distant world, revealing its complex geology and surprising activity. In comparing the two, the scale disparity between terrestrial and extraterrestrial objects is striking. While Russia's size is tangible and observable, Pluto's smaller size is part of its charm and mystery as an enigmatic member of our solar system. Together they serve as a reminder of the vast differences in scale and perspective between our home planet and the universe beyond.
Antarctica, the southernmost continent on Earth, is often associated with its icy expanse and extreme cold, but it is also classified as a desert. This designation might seem counterintuitive given its thick layers of ice and snow, but it aligns with the scientific definition of a desert, a region that receives very little precipitation. Antarctica receives an average of only about 50 millimeters or 2 inches of precipitation per year, mostly in the form of snow. This is less than the Sahara Desert, which averages about 76 millimeters or 3 inches annually. The low precipitation in Antarctica is due to its extreme cold and the behavior of atmospheric moisture. Cold air holds far less moisture than warm air, and the frigid temperatures over Antarctica prevent significant amounts of water vapor from accumulating in the atmosphere. As a result, snowfall, the primary form of precipitation in Antarctica, is sparse. Additionally, much of the continent is shielded by high-pressure systems that further inhibit the formation of clouds and precipitation. Despite being covered in ice, Antarctica's conditions are strikingly similar to those of a traditional desert. Most of its surface is dominated by permanent ice sheets that have accumulated over millions of years. However, there are regions of the continent such as the McMurdo Dry Valleys, where the landscape is completely devoid of ice and snow. These areas are among the driest places on Earth, with some spots receiving no measurable precipitation for thousands of years. The classification of Antarctica as a desert highlights the unique interplay of cold and dryness. While its landscape appears vastly different from hot deserts like the Sahara, they share the defining feature of aridity. Interestingly, the Sahara, with its scorching temperatures and sand dunes, experiences occasional rainfall and even rare flooding events, which are almost non-existent in Antarctica's interior regions. Antarctica's desert status has profound implications for its ecosystem and research potential. The harsh conditions make it one of the most inhospitable places for life, with only specialized microorganisms, hardy lichens, and a few invertebrates managing to survive in the ice-free zones. However, the continent's dry and stable environment is ideal for scientific studies, such as drilling ice cores that provide insights into Earth's climatic history over hundreds of thousands of years. The juxtaposition of ice and desert in Antarctica serves as a reminder of Earth's incredible diversity and the adaptability of the natural world. It challenges traditional notions of what a desert looks like, demonstrating that aridity can manifest in both blistering heat and freezing cold.
The Amazon River, one of the most iconic and mighty rivers on Earth, has a fascinating geological history that includes flowing in the opposite direction millions of years ago. Today, the Amazon flows eastward across South America, emptying into the Atlantic Ocean. However, evidence from geological and fossil records indicates that during the Mesozoic era, around 100 million years ago, the river once flowed westward toward the Pacific Ocean. This reversal in the Amazon River's flow is closely tied to the dramatic geological changes that shaped the South American continent. At that time, South America was still connected to Africa as part of the supercontinent Gondwana. The Andes Mountains, which now form a massive natural barrier along the western edge of the continent, had not yet formed. Without the Andes, the continent's topography sloped gently westward, and rivers, including the early Amazon, drained toward the Pacific. The rise of the Andes, which began about 65 million years ago due to the collision of tectonic plates, profoundly altered the continent's geography. As these mountains rose, they created a massive physical barrier that blocked the Amazon's westward flow. This blockage caused water to accumulate and form vast inland seas and swamps, effectively reversing the flow of rivers in the region. Over millions of years, as the Andes continued to grow and the landscape adjusted, the Amazon River found a new path eastward towards the Atlantic Ocean, which remains its current course. The reversal of the Amazon's flow had profound effects on South America's ecosystems and biodiversity. The transformation of the river's direction and the subsequent drainage of the inland seas reshaped the continent's habitats, influencing the evolution of its flora and fauna. Today, the Amazon River and its basin are home to the most diverse ecosystems on the planet, including the Amazon rainforest, which owes its existence in part to these ancient geological shifts. Evidence for this ancient reversal comes from sedimentary deposits and fossil records. Geologists have identified sediments along the Amazon's current course that were once deposited by rivers flowing in the opposite direction. Additionally, fossils of marine organisms have been found in regions that are now far inland, providing clues about the ancient inland seas that formed during the river's transitional period. The story of the Amazon River's reversed flow is a testament to the dynamic nature of Earth's surface and the powerful forces of plate tectonics. It illustrates how geological processes over millions of years can reshape continents, redirect massive rivers, and create entirely new ecosystems. This history adds another layer of intrigue to the Amazon River, a natural wonder already celebrated for its scale, complexity, and ecological significance.
Point Nemo, a remote location in the South Pacific Ocean, holds the distinction of being the most isolated spot on Earth. Officially known as the oceanic pole of inaccessibility, it is located at a point that is farthest from any landmass. The nearest land to Point Nemo is over 2,688 kilometers, or about 1,450 nautical miles away. To put this distance into perspective, the International Space Station, orbiting Earth at an altitude of approximately 400 kilometers, or 250 miles, is often closer to Point Nemo than any human-inhabited land. Point Nemo is named after Captain Nemo, the famous submarine captain from Jules Verne's novel 20,000 Leagues Under the Sea. It was identified in 1992 by survey engineer Hervoge Lucatella using computer modeling to pinpoint the exact location. Point Nemo lies in the South Pacific Gyre, a vast expanse of open ocean known for its relative lack of marine life and scarce human activity due to its remoteness and nutrient-poor waters. The region surrounding Point Nemo is so isolated that it is often called an oceanic desert. Few species inhabit this area, as the lack of nutrient-rich currents makes it difficult for marine ecosystems to thrive. The absence of human activity also means that the waters here are largely untouched, making Point Nemo one of the least polluted areas of the world's oceans. Point Nemo has another intriguing association. It is often referred to as the spacecraft cemetery. This is because it is the designated location for controlled re-entries of decommissioned spacecraft and satellites. Its remoteness makes it an ideal crash site, minimizing the risk of debris causing harm to humans or property. Since 1971, more than 260 spacecraft, including parts of the Russian Mir space station, have been intentionally deorbited to splash down near Point Nemo. Despite its isolation, Point Nemo has captured the imagination of adventurers, scientists, and storytellers. It serves as a powerful symbol of Earth's vastness and the limits of human exploration. Its location, far from human civilization, also underscores the interconnectedness of Earth and space, as the ISS orbiting above represents humanity's presence beyond the planet, while Point Nemo below remains one of the least touched places on Earth. Point Nemo is a fascinating example of how geography and technology intersect to reveal the planet's extremes. Its status as the most remote location on Earth highlights the scale of our planet and the sheer expanse of the oceans that cover more than 70% of its surface.
Thank you for watching. We hope these mind-blowing facts left you amazed and inspired. Don't forget to like, subscribe and hit that notification bell because there's plenty more where that came from. Stay curious and we'll see you in the next one.